Hi dear students, today we have come the last video of motion. In the previous class we have discussed about mass and weight, and today we will discuss little more difficult numericals, which may come from this chapter, and then this chapter will over. So after completion of this chapter I will give another assignment from this chapter as I have given assignment from the previous chapter. Okay, so let's see what numericals we are going to do here. See, in the chapter motion, we have discussed one very important topic, that is average speed. And we have done some numericals based on average speed. Here, now we will do little more difficult numerical from average speed. That numerical is not given in your exercise, but it is given in your example. So that's why that type of numerical it is need to do. Let's see. So assume one point I have taken A. Okay, so A is a point and B it is another point. Assume these 2 points are just identifying 2 places. Okay, assume one place is Haldia, another place is Kolkata. Now assume we have taken a car. Okay, and by the help of the car we have just gone from Haldia to Kolkata with a speed of, we can take it is V1. Okay, so with the speed of V1 we have started from the point A and gone to point B. So we have reached here. Okay, so that is our destination, and now after going Kolkata we will not stay there. So after doing our work or after roaming the places where we want to go, then we have to start from here. Okay, we will start from here by the same car and we will come to our place again. Okay, maybe in my drawing the cars are not looking same, so whatever, assume the cars are same. Whenever we have gone with the speed of V1, but whenever we have returned with the speed of V2. We have gone with the speed V1, and when we return, then our speed is V2. Definitely, whenever we have gone by a speed V1, then the time we have taken to reach to the point B, that is T1, we are assuming. And when we have returned, see, as our speed is changed, definitely the time we have taken there, that will be changed, that should be T2. So with the speed V1 we have reached a point B by time taking T1, and with the time T2 with the speed V2 we have reached to the point A. Now the question has come, what will be the average speed of the car? Because you see the speed of the car is not constant. At the time of going it is V1, at the time of coming it is V2. So what will be the average speed of the car? How we can able to find it? Let's see. When it is told to find the average speed, we know the equation of average speed is total distance covered by body divided by total time taken. Okay, now you see, is it given how much distance you have covered? You will say, sir, no, it is not given. But here we have to assume one thing. What? See, the distance from A to B will be equal to from distance B to A. How much distance it will take to Haldia to Kolkata, that will be same if you come from Kolkata to Haldia by same road. So assume they have gone and come by same road. So the distance covered at the time of going, same distance it will cover at the time of coming. So we have to start from here. Let the distance from A to B is D. Okay, so that is our assumption, that from A to B the distance is D. Acha, whenever it gone from A to B, it is covered a distance D, and whenever it is returned from B to A, it covers again a distance D. So if it is asked that total distance covered by the vehicle, what it will be? Now, at the time of going it is D, at the time of coming it is also D. So total distance covered, it is 2D. Now it is asked how much total time taken. Now total time taken at the time of going it is T1, at the time of coming it is T2. So total time it should be T1 plus T2. Now the problem is that this T1 and T2 we have to represent in the form of V1 and V2. How? Let's see. Now you might be thinking, sir, why we have to describe this way? Because we just want to find one equation by which we can able to find out the average speed of this type of question. If I want to represent the time with the help of the speed, how we have to do? See, we all know that speed equals to distance by time. That we all know. So from here we can write time equals to distance by speed. Simple cross multiplication. Distance by speed. If speed equals to distance by time, so definitely time equals to distance by speed. So from this equation, if it is told, what will be the time T1 then? So time T1 equals to how much distance is covered in time T1? Now you will say that distance is D, because A to B, that distance we have taken, it is D. And what is the speed? V1. So T1 equals to, we can write D by V1. Okay, as per this equation, the time equals to distance upon speed. Okay, so here in first case T1 equals to D by V1. So here we have to write when the car goes A to B, and when it returns, that time the time is T2. Achha, how much distance it covers? Obviously it is also D, but the speed is changed, so it is D by V2. So here we have to write when the car returns B to A. So in every case the time it will be D by V1 and T2 equals to D by V2. Why? Because we want to represent the time in the form of V1 and V2. That's why we have done it. Now from here, if it is asked that what will be total time? See, we have already written total time equals to T1 plus T2. So T1 plus T2 means D by V1 plus D by V2. See, T1 equals to D by V1, T2 equals to D by V2. From here we can take common D. So take it, D by D common, 1 by V1 plus 1 by V2. Okay, now do the LCM and calculate it. D, if I do the LCM, so it will come V1 into V2. Okay, so here at the top it is V2 plus V1. So that is our time. D into V2 plus V1 by V1 plus V2. So you thought that it's a long thing we have made. Now what we have to do? Simple thing. We have to find average speed. How? Let's see. I have to erase the first portion, otherwise it is difficult to write. So whenever we have to find the average speed, we have already written that average speed equals to total distance covered by the body by total time. Achha, what is the total distance? See, we have find total distance is 2d, because d distance we have gone and we have returned also d distance. So total distance, it will be d plus d, 2d. We have to write 2d here. Divided by total time. So what is the total time? We have find out t1 plus t2. So t1 plus t2 equals to d by v1 plus d by v2. So from here, d into v2 plus v1 by v1 into v2. So we have to write here d into v2 plus v1 by v1 into v2. Now this one, it will be going up and d will be cancelled out. So the answer will come 2 into v1 v2 by v1 plus v2. So what is v2 plus v1? That is v1 plus v2. So that will be the average speed. So if any numerical, it is given like this way, that some distance is covered by a velocity, by a speed, and when it returns, then the speed is changed. In that case, the average speed will be 2 into v1 v2 by v1 plus v2. Okay. Now, what question is given to your book in your example? Based on that question, we have to do one numerical. Okay. So let's see what question is given. So in your book, the example number 3. Okay, so it is the example. So example number 3, it is given a train travels from Agra to Delhi at a constant speed of 50 km per hour. So assume it is Agra and here it is Delhi. So a train travels from Agra to Delhi with a speed of 50 km per hour. So assume this is your speed v1, clear? And it returns Delhi to Agra with a constant speed 40 km per hour. So when it returns from Delhi to Agra, then your v2, it is 40 km per hour. Okay, so two speeds are given. Agra to Delhi, it gone by v1, and Delhi to Agra, it come by v2. Two speeds are given. Now the question is, find the average speed. We know average speed is equals to 2 into v1 into v2 by v1 plus v2 as per the equation. Achha, what is v1? 50. So 2 into 50, what is v2? 40. And v1 plus v2? 50 plus 40. So it is 2 into 50 into 40 by 90. So let's divide it. Clear? So it is coming 0, it is cancelled out. So 50 to the 100, 100 4 the 400 by 9. Now if I want to convert it in decimal, then it will come 9 4s are 36, then 4, 9 4s are 36, so 44.44 kilometer per hour. See whether our answer is correct or not. Yes, our answer is correct. That is 44.4 or 44 kilometer per hour. So by this way, we can able to find the average speed if the two speeds are given. And in that case, one thing we have to remember, that by that speed we have to cover same distance. Then only we can able to use this equation. Okay, if they are not covering same distance, then we cannot able to use this equation. Okay, now we'll go for another question that is also given to your book. That also we can do by using the same equation. Okay, and based on that I will also give you some question, so you have to use this equation and you have to write the answer. Let's see. So next question, it is told, question number 4, that a boy walks from his home to post office at a distance of 0.5 kilometer in 20 minutes. Okay, so here the question, it is little difficult. It is not given by this numerical. It is coming little different. Okay, so what it is told, a boy walks from home to post office. Okay, so one place it is home, another place it is post office. The distance it is told, it is 0.5 kilometer. That is the distance, not the speed. Speed is not given. So the distance 0.5 kilometer, it is covered by a time 20 minutes. Okay, this thing is given. Next, then he returned to his home in time 25 minutes. Post office to home, it come by a time 25 minutes. See, at the time of going, if I cover 0.5 kilometer, so at the time of coming also, I have to cover the same distance, that is 0.5 kilometer. Okay, how much distance I have to cover at the time of going, at the time of coming also we have to cover same distance. Now here see, the speeds are not given. Instead of speed, what is given? Distance and time. Achha, if distance and time is given, can we able to find the speed? Yes, of course, because we know speed equals to distance by time. Okay, so here what is the distance? 0.5 kilometer. What is the time? 20 minutes. Now see, we can able to find the unit of speed either in kilometer per hour or meter per second. But here it is, if I want to find the speed, it will be kilometer per minute, because time is given in minute. So here the time we have to convert into hour. Okay, so here it is given 20 minutes. So time to go from home to post office, T1 is equals to 20 minutes. So 20 minutes means how much hour? 20 by 60 hour. That means 1 by 3 hour. Achha, time to return from post office to home, that we have to take T2. What is the time? 25 minutes. Achha, 25 minutes also we have to convert into hour. So it is 25 by 60. So let's divide it by 5. 5 5s are 5 12s are. So it is 5 by 12 hour. Now can we able to find the speed, because distance is given and what should be the speed? Let's do it here only, because after that we have to remove it and we'll go there. So speed of going. So how much speed of going it is? So distance is 0.5 and time it is taken at the time of going, it is 1 by 3 hour. So 3 will come up. So it is 1.5 kilometer per hour, and that will be our speed V1, because that speed whenever we have gone from home to post office. Okay, so that is 1.5 kilometer per hour. Now we have to write speed of return. So in case of return, we have come by same path, that is 0.5, and time is 5 by 12. That much kilometer per hour. So here, if we have to do, so it is 5 will be cancelled out, that will be 0.1, and 12 will come in here, so it is 1.2 kilometer per hour, and that is your V2. Okay, now the formula is just like the previous, because we need the speed of going and the speed of coming, and when we will get the speed of going and coming, then our equation is already given here. What? It is 2 into V1 into V2 by V1 plus V2. So here the average speed will be average speed of the boy. So what will be the average speed of the boy? 2 into V1 means 1.5, V2 that is 1.2, and V1 plus V2, 1.5 plus 1.2. So let's calculate. 1.2 into 1.5, it is 3. 3 into 1.2, it is 3.6 by 7, 2.7. So point will be cancelled out. 4s are 3s are. Okay, so 3 1s are 3, and here it is 1. 0.3 3s are 9, then 1 3 3s are, so 1.33 kilometer per hour. Let's check whether our answer is correct or not. Yes. Where? Okay, so average speed, it is the same. Okay, so here it is calculated 0.37 meter per second. We have converted into kilometer per hour. That's why our answer is not coming, because here it is written in meter per second. If we convert it in meter per second, then see whether it is coming or not. So if it is converted in meter per second, then it will be 1.33 into 5 by 18. So multiply 15, 6.65 by 18. So here it is 0.37. Okay, so let's see, it is 0.37 meter per second. See our answer? Yes, it is correct. Okay, so we have to go by our process, whether it is given in kilometer per hour or meter per second. Our answer is correct. Okay, so my target is to remember you this equation, that is V average, that is average speed equals to 2 into V1 into V2 by V1 plus V2. This equation we can only use that the body will cover same distance in two different speed. Okay, if any doubt, then ask. So we have discussed some hard numericals from average speed. Now we will just discuss about another topic, another numerical of mass and weight. Though we have discussed many things about mass and weight in our previous video, but here, before doing numericals, I just want to remember that how we can able to find it. So whenever we are discussing about mass and weight, mainly we are finding the weight of a body. So whenever we are finding out weight of a body, how we have to find out? We are finding it by getting the mass of a body into force on unit mass. Okay, that is the equation by which we can able to find the weight. So weight of the body we can write W, Mass of the body, it is m, and force on unit mass we have denoted by g. So that is the equation of W equals to m into g. Whenever we have to find weight of a body on surface of earth, in that case we can get by mass of body into force per unit mass due to Earth's gravity. Okay, so here also we written W equals to m into g of E. So here g of E means force per unit mass due to Earth's gravity. Force per unit mass due to Earth's gravity, and that value we have told that GE equals to 9.8 Newton per kg in SI or 10 Newton per kg. Okay, any of the two value we have taken. Now you might be asking, sir, in the previous class we have told that we have taken the force per unit mass due to Earth's gravity, that only G. So why you have written G of E? See, whenever we are finding the weight, generally we finding on the surface of Earth. So that's why G and G of E we have taken for same purpose. But when we want to find the weight on another planet or another satellite, then we have to mention G of E, which represent, that is, the force per unit mass due to Earth's gravity. Here you see, if I want to find weight of body on moon, so that in that case mass of body into force per unit mass due to moon's force of gravitation. And whenever we have written this unit mass, you know that unit mass means 1 kg. For us, unit mass is 1 kg. So force on 1 kg mass due to moon's gravitation. Okay, so it will be W equals to, so here for Earth we have written WE, for moon it is WM. So WM equals to M into G of M, where this G of M is the force per unit mass due to the moon's force of gravitation. Okay, because the force of attraction, it is not same in every planet or satellite. For Earth, whatever the force is there, for another planet or another satellite, it will be changed. I have told in the previous class that this force depends on the mass of the planet or the mass of the satellite. Okay, so for different planets, for different satellites, the value of GM is different. Now it is told that weight of a body on moon is equal to 1/6 of weight of body on Earth. Means on Earth the weight of any body is more than the moon. How much time? 6 times. So if I retain weight of the body on moon, that should be Wm, and it is equals to 1/6 of We. So We is weight of the body on Earth, Wm is weight of the body on moon. So Wm, it is written as this mgm, weight We, so it can be written as 1/6 into mge. Now you might be asking, sir, how do we know? See, this is not calculated or not done by me. It is done by the scientist, it is done by experiment, and then it is shown by some calculation that weight of the body in moon, it is 1/6 times of the weight of the body on earth. Now you see, we all know mass of the body that should remain same wherever it can be taken. So mass, it will be cancelled out. So G of M, that is equals to 1/6 of G of E. Now if I put the value, see what is the value of GE? So it is here, that is 1/6 of, we have to take it is 10. So it is easy to calculate. 3s are 5s are. So it is 5/3. So 5/3 means it is around 1.66. Okay, that much of Newton per kg. So it is clear, in case of Earth, on 1 kg mass, the force is 10 Newton. And for 1 kg mass in moon, the force is 1.66 Newton. So if any one person thought that his weight is much, just like me, in Earth, so it is not that exactly his weight is increasing. He is on the wrong planet. Rather you go to moon and there your weight will be less and you will feel that you are thin. Okay, so this is the whole story of the numerical. So from here the numericals come. What type of numerical has come? Let's see. Next we will do some numerical from mass and weight. Okay, so some easy numerical we have seen in the previous class. Here we have to do a little more difficult, just like we have to do example 7. It's a question from your example. Question is, a boy of mass 40 kg. So what things are given to you that you have to write first. So given mass is equals to 40 kg. That is the mass of the boy. Next, if the pull of gravity on 1 kg on the surface of Earth is 9.8 Newton, that means it is given force of gravity on 1 kg mass at surface of Earth. So that one is denoted by G. So G is given 9.8 Newton per kg. Okay, it is told. And next it is told that at the surface of moon it is 1.6 Newton. So force on moon on 1 kg is equals to 1.6 Newton. And here it is 1 kg, that is 9.8 Newton. So per kg we have to not write here as we have mentioned 1 kg. If we have not mentioned, then we have to write. So it is G of M and it is G of E. So that thing is given to us. One, it is 1.6 and it is 9.8. Now the question is the weight of the boy at the Earth's surface. So first question, weight of boy at Earth's surface. So that we all know, that is WE equals to M into G of E as per the equation we have done earlier. So what is the mass? 40 kg. What is the GE? That is 9.8. So we have to multiply. So 392 Newton, that much of weight at the surface of Earth. Next question is, at the surface of moon, what is the mass and weight of the boy? See, we all know that mass of a body cannot be changed if you taken it to another place. So mass on moon, that should remain same. What is on the surface of Earth? That is 40 kg. And weight on moon, so that should be Wm, that is m into gm. What is the mass? 40. What is the value of gm? 1.6. Multiply it. Okay, so it is 64 Newton. So let's see the answer. Yes, it is 392 and 64 Newton. Okay, so this type of question may come. Now we'll do one more question, that is from exercise and question number 8. Okay, and if you can able to do that question, I think you can do any question from mass and weight. So let's see what question is given in question number 8. So make a habit, whenever we have to see one numerical, that time what information is given there, that we have to write. So that is question number 8 in exercise. And what thing is given to us? Number 1, the weight of the boy of mass 6 kg on moon is 10 Newton. So mass of body, that is given 6 kg, because kg is the unit of mass. Whenever we have to see kg, so that is definitely it is the mass. And the weight of that mass on moon, so weight on moon, it will be how much? That is Wm, and that is equals to given 10 Newton. Clear? Very easy. If a boy of mass 30 kg goes from earth to moon surface, what will be his mass and weight? Now see, by this statement, so the another part is given that we have to do later. But by this statement, what we can able to find out? Weight of the moon, that is given Wm, and that can be calculated by m into gm. Right? Here you see mass is given and the weight is given. So can we able to find gm here? Yes. So gm equals to Wm by small m. What is the value of Wm here? 10. What is the value of mass? 6. So it is 5 by 3. Okay, so write it. 5 by 3 Newton per kg. Let it be like it. Okay. Now, next thing it is given the mass of a boy of 30 kg. So we have to write mass of boy, small m. So let's take it capital M. It is equals to 30 kg. Now it is asked what will be his mass and weight at moon's surface. So at moon's surface we know mass on moon, that will be remain same, that is 30 kg, because mass of a body cannot be changed. Next, weight on moon. So weight on moon of that boy, that we have to take W, that is equals to mass of the boy into gm. Achha, mass of the boy it is already given 30. Gm we have calculated 5 by 3. Yes, that is the value of gm we have calculated. So 3 tens are 30. So here it is 50 Newton. Okay, so that one is the weight of the boy on moon. If it is told, though it is not written over here, if it is told, achha, what will be the weight of the boy on earth? If it is asked, weight of boy on earth, then how we have to calculate? So We equals to m into Ge. Mass of the boy 30. And the value of Ge, we can take 9.8, we can take 10. So if we take 10, that will be easier. So this much of Newton. So it should be 300 Newton. So if it is asked, though it is not asked, so if it is asked, what will be the weight of the boy on earth? That will be 300 Newton. What will be the weight of the boy on moon? That is 50 Newton, which is asked in your question. So this type of questions may come in exam. Okay, and I'll give some mod questions, okay, some model questions to you to do or to practice this. Okay, thank you.